Hello, my name is GRV.SRIRAM. I am from CSC Data Science Department. This presentation course title is Data Structures, and the topic title is Calculating Joint Probability Distributions in Study Directed Cyclic Graphs. Calculating joint probability distributions in study directed cyclic graphs, integrating local data and domain casual knowledge. The challenge of cycles in probabilistic graphical models. Understanding complex systems requires more moving beyond traditional acyclic assumptions. Directed cycles inherent in many real-world feedback systems present significant challenges for calculating joint probability distributions. DAX versus cycles. Traditional Bayesian networks rely on directed acyclic graphs DAX for joint distribution calculation. Second thing, feedback systems. Directed cycles naturally arise in feedback systems and complex causal relationships such as economic models or biological pathways. And third thing, classical assumptions. Cycles cycles break classical assumptions, complicating inference and probability, computations and requiring novel approaches. Why directed cyclic graphs matter? Real world systems frequently contain feedback loops from biological processes and economic markets to epidemiological spread. Ignoring these cycles can lead to flawed predictions and incorrect causal conclusions. Ignoring cycles can lead to incorrect causal conclusions and flawed predictions. For instance, in a medical context, a COVID-19 diagnosis and the presence of fever symptoms can mutually influence each other over time, forming a cyclic relationship that traditional DAX cannot adequately capture. Foundations con- constraint based semantics for cyclic based networks. Recent advancements provide a robust theoretical framework for handling cycles. Bayer ETL 2023 introduced groundbreaking semantics that ensure joint distributions align with local conditional probabilities and independencies. Limit semantics. They propose limit semantics via infinite unfolding, which are computable through Markov chain constructions. Generalized approach. This approach generalizes DAG-based methods, allowing rigorous handling of complex cycle dependencies without simplification. Rigorous handling. The framework ensures consistency and accuracy in probabilistic reasoning within cyclic graphs. Incorporating local data and domain casual knowledge. Effective modeling of cyclic graphs require, requires a blend of empirical data and experts' insight. Local conditional probability tables CPTs can be derived from diverse sources such as multiple scientific studies or heterogeneous data sets, providing granular probabilistic information. Concurrently, domain knowledge offers invaluable causal constraints and background structure. Zeng ETL 2024 demonstrated that Integrating prior knowledge significantly enhances the learning of local causal structures, leading to improved causal identification in complex systems. This synergy between data and knowledge is critical for building accurate and robust cyclic models. Methodology: Markov chain equilibrium semantics. Cooley and Crowley 2013 provided a powerful framework for modeling cyclic causal systems, treating them as Markov chains. Practical computation strategies: translating theoretical foundations into practical applications requires sophisticated computational techniques. These strategies enable efficient learning and inference in complex cyclic graphs, such as potential functions. These represent the joint distribution as a globally normalized product of interventional potential functions like Murphy 2012 and Schmidt. Convex optimization. Parameter estimation is formulated as convex optimization problem, enabling efficient learning from observed data. The next one, the convex relaxation. Convex relaxation techniques facilitate simultaneous structure and parameter learning in cyclic graphs. Leveraging prior knowledge and handling errors. Integrating prior knowledge is essential for building more reliable models, but it must be done carefully to avoid introducing biases or errors. This process involves a multifaceted approach. Casual priors, large language models, and expert insights can provide valuable casual priors informing the initial structure of the cyclic graph. Chen et al. 2023. Robust algorithms. Robust algorithms are employed to identify and mitigate erroneous prior causal statements, ensuring the accuracy of the model. Reliable distributions. The seamless integration of local data with domain knowledge ultimately yields more reliable and consistent joint distributions. Visualizing the process. This diagram illustrates the comprehensive framework for calculating joint probability distributions in study directed cyclic graphs, integrating both local data and domain causal knowledge through Markov chain equilibrium semantics. Conditional probability tables, CPTs. Domain causal parameter learning, CPTs, local conditional probability table. Here we can see Markov is mapped to all of these things, visualizing the process. And conclusion: towards reliable joint distributions in cyclic causal models. Directed cycles are a fundamental feature of many complex real-world systems. While they pose challenges for traditional probabilistic graphical models, modern semantic frameworks and computational strategies now allow for their rigorous analysis. Manageable cycles. Directed cycles are unavoidable but are now manageable with modern semantics, opening new avenues for complex and system analysis. To accurate calculations, combining local data, domain causal knowledge, and Markov chain equilibrium methods enables accurate point probability calculations, improved outcomes. This foundation paves the way for improved causal inference, prediction, and decision making in feedback rich systems. Thank you.